or interval points. That'd be 2 pi.
Okay, we're on page 13. Let me go over. Let me just go over these problems here. That was part of your homework. Okay. Your check-in quiz on Monday, you'll have more straightforward problems like these where you're given the function and you're just listing out everything and you're graphing. So, and then the other part is going to be ones that are that we probably need to spend more time on, which is the worksheet that you picked up. Okay, but let's go over these first, and then I'll go over that worksheet in detail. So number 11, first thing we can do is try to get that 2 theta or 2 to factor out. Once that 2 factors out, we have to ask ourselves 2 times what value will give me 3 pi over 2. I know I need that 3 pi, but I need that 2 in the denominator. But if I can make that 2 over 4, then I'm able to get that 2 to work out. We can always distribute through, and we know that if we distribute through, we should always be able to get back to our starting point. So that's always a quick way to double check ourselves that we have the correct C value. Okay, once we have that, our period is 2 pi over 2, which reduces to be pi. Interval is pi over 4. Start at 0, and you start building your increment intervals until you reach your pi, or the length of your period. And then we can look at the phase shift, which is 3 pi over 4. Plus, that means we have to shift everything left 3 pi over 4. So I subtract everything by 3 pi over 4. My y value has been adjusted with a new amplitude of 3. Now I can sketch my graph. Oh, sorry. There's also a vertical shift of 0.5. So our dotted line goes on 0.5. And we're going to treat these not as y values, but rather as vertical shift by these number of units. So here, if I see a 0, I'll be graphing on the dotted line. If I see a positive 3, I'm going to count up 3 units from the dotted line. If I see negative 3, I'm going to count down 3 units from my dotted line. Okay, so whenever you see 0, I know the tendency is you want to go ahead and put it on the x-axis, but I think it's helpful if you have a different color pen just to remind yourself, oh, any 0 is going to go on my dotted line on this new center of my graph. Okay, any questions with number 11? All right, number 12. We also have to factor that pi over 4 out. So we have to ask ourselves, once that pi over 4 comes out, pi over 4 times what gives me pi over 2? Ultimately, I need a 2 in the denominator. I need to get that 4 to be a smaller value. I need the pi. So, well, sorry, the pi is already there, so I just need a 2. Distribute through to convince ourselves there. So pi over 4 theta plus 2 pi over 4. 2 pi over 4 reduces to pi over 2. We know we have the correct answer. We never have to guess what that value is. Well, we can guess, but we can always confirm that this is correct. Right? Okay, period, 2 pi over 4. Get that to be 8. Interval is 8 over 4, which is 2. We build our subintervals, and then we realize that we have to shift everything 2 units to the left. So we subtract 2. And our the only adjustment with our A value is there's a negative. So the amplitude is going to stay 1, but the reflection is going to cause the signs of the original y values to change. Okay. So negative 1.5 is going to be our vertical shift. So I plot my dotted line right at negative 1.5. And then from, this is now my new 0. And from here, I'm just going to either go down 1 unit, stay on the dotted line, or move up 1 unit. Okay. Any questions here? Okay, so we can expect to see one of each type of problem on the check-in quiz on Monday, where you have one sine and one cosine, and you're going to have to go through all the transformations that we're seeing here. Okay. Any questions? Okay, let's go to the worksheet that I gave you, so we can practice with these other types of problem where you're given the graph and you have to figure out what the equation is. Let's start with number 2. Okay, number 2 is going to be the easier one because it matches the cosine graph a little better. So it's the same graph, but we'll start with the easier one, and then we'll talk about how we can work in the sine function. So I'm looking at this function here, and I'm looking at the fact that it's going from peak to peak, and we can kind of recognize that as a cosine function without any horizontal shifts, right? That should be good to go with the cosine function. We know our C value is not going to have to change. So I like to start off by thinking about, well, what's my center? Because it's obviously not what we expect with 0. So we have to kind of look for the center and kind of count. So where do you think that center is for this graph? -4. So this is going to be helpful because if we can find our center, we're going to have a much easier time finding our amplitude and our A value. Okay. So now that I have my center, I'm able to count from the center to the max or center to the min. These should all be the same distance. And so what is that distance? 3. Okay, so we can say our amplitude is 3. Okay, amplitude is 3. Period is going to be from beginning of the cycle to the end of the cycle. So what's the period of this cosine function? 4. Okay. Phase shift, we know that's not going to be, we're not going to have any phase shift because it's already starting exactly where we want with the cosine function. But there is a vertical shift, so I'll say Vs. And what's that vertical shift going to be? Good, right? So if you have that dotted line, that's always going to match whatever that vertical shift is going to be. So down 4. Okay, we should have enough information to start building our A, B, C, and D value. Okay, so we know our A value is just going to be a +3. It's starting at the peak of our cycle, so we don't have to do any reflection, right? This is a +3. No need to do any adjustments there. Okay, to find our B value, we're going to have to go through our formula, right? We know the formula for period is 2 pi over b. So period is 4, so I'll say 4 over 1 is equal to 2 pi over b. Cross multiply, divide by 4. B equals pi over 2. Are we okay with that? Okay, so B equals pi over 2. Our C value, we don't have to do any shifts. This is exactly what we would expect from a cosine graph. So C is 0, and D, we said, is -4. Okay, we should have enough information to write our final cosine function. No need for brackets since we don't have to add or subtract a C value to our theta. Okay, and you can put it in this space here. Okay, so this is the easier one because no phase shift required. What we see is basically the cosine graph. Okay, good so far? Okay, let's go to number one. Now, number one, we can carry a lot of information over. It's going to be the same graph. We just have to worry about a sign variation of this, or being able to name this in terms of a sine function. So a lot of things we're going to carry over, right? Our center is still -4. So we know our D value is the same, our A value is the same. But the challenge here is we're trying to create a sine function out of this. Now, now we can't, there are multiple ways that you can get this into a sine function, because you could go through reflection, you can maybe shift left or right, but I'm just going to go after what I think is the easiest one. So I'm going to find and create the closest sine function nearby. And then once I can get a sine function that looks similar to this cosine function in terms of the period and the amplitude, then I'm going to create that function, and then the final moment, I'm going to decide which direction do I want it to shift to make it turn into this graph that I'm ultimately trying to find. Okay, so I see a sine function nearby. I know a sine function starts at 0 and it starts its rise to the right. So I'm just going to create a sine function that is nearby, and then I'll worry about the shift. But I kind of want to mirror the size and of the period and the amplitude. So I'm just going to make my way through my sine graph. So I think this is the easiest way, just to force ourselves just to write a sine graph or sine function for that dotted line. And then at the very end, we can worry about what to do with the phase shift. Okay. So if I'm just focusing on what I have there, dotted line, a lot of things will carry over, right? The period is 4, amplitude is still 3. So I'm not going to redo the work here, but we know that our B value is going to be the same as well. A value is also the same. C, we know there's a shift that has to occur. We'll leave that for later. D is still the same, right? D is still -4. Okay. So let's create a sine function for what we see, and we'll leave the appropriate space for the final shift that we want to make. Okay, so what I have in front of me is the function for this graph that I have in green. But that's not the final graph that we want, right? We want that shifted. So which direction do we want to shift to make it turn into the graph that we want? Left. How many units? 1. So it's going to be what? Good. +1. I think this is the easiest way to do it. That way you can just kind of split it up into smaller chunks. Solve an easier problem first, and then once you have that down, then move it to where you want it to move. I hear some students were, shifting it a little further left, further right, and doing a reflection, which is fine. So, but I think this is the easiest one. But if you shift it further or create a reflected version of this, that's also fine. If you want me to check your work, I can check your work a little bit later. Yes?
Does that have to be +1 or could it be -1? Does it have to be like really specific?
I think a -1 is not going to quite get where we want it to, right? Because if I take that graph in green and shift it over 1, I don't think it's going to quite match that cosine graph. I may have to shift it maybe 1, 2, 3 to the right. But I think the easier shift is just going to be shifting it to the left one. Does that make sense?
Yeah.
Okay. So ultimately, there's many different versions of this answer, but I think this is the easiest one to find. But if you have other versions on the quiz, if it's correct, I'm not just grading just off this I'll look at your work, and if yours matches, that there's multiple answers that you can provide. Okay, so phase shift, we can say left 1 unit. Okay, and then vertical shift, same thing, down 4. Okay, any questions with number 1 or 2? Okay, let's turn to the back. Okay, number 3 says write the sine function with period of pi with a minimum value of -5 and a maximum value of 1. Okay, let's start with the easier thing first. Let's start with that period value and work our way to our b value. Okay, we'll get our b value, and then we can figure out how that minimum value of -5 and 1 can help us with the rest of forming our equation. Okay. Cross multiply, divide both sides by pi, b is equal to 2. Okay, let me just see, let's see if we can start sketching out what this graph could look like. Okay. We want a period of pi. Sine function starts at 0. So I'm just going to go ahead and start creating a rough version of this graph, the easiest version of this graph that I can create. Period of pi. So I know each subinterval is going to pi over 4. It's going to create a few markings here. Now, I want my graph to have a minimum of -5 and a maximum of 1. So I'm just going to mark it and see if I can figure out the rest after I have this in place. So we know our sine graph is going to have to rise to +1 and then down to -5. But you know everything is going to be kind of symmetrical in terms of from the dotted line to our max and mins. So we kind of just have to look a little bit more closely here. Where do you think our shift is going to be? Where's our dotted line? Where's our new center? -2. Okay, let's try that. Let's confirm. This should be the same distance to the max as it is to the min. So from the center, I count 1, 2, 3. At center, I count 1, 2, 3. So we know that we're right at the center. And this is helpful because now we can find the a value and we can find the d value. Okay. I'm just going to sketch what this graph could look like here, though, just to kind of convince myself. Okay, so we have our b value, which is 2. Can we find our a, b, c, and d value? Okay, what's our a value? 3, right? So from the center, we're counting 1, 2, 3. That's a max distance of 3 from the center. C value. Right, we're creating the simplest function that we can create, so we're just going to do a shift of 0. And what's our d value? -2, where the dotted line is. Okay, so let's write our sine function. Okay, yes. If you can do it without the graph, that would be okay. Yeah. Okay, number 4. Write a cosine function with a period of 4 pi whose maximum value is -2. So the difference here is that it doesn't give us that minimum value, which means that you can really choose any minimum value you want. So basically, we have we may have different variations of answers, but I'm just going to see what is going to be the easiest one to create. But I'm going to leave that up to you. Okay, so see if you can. I think it's helpful to sketch a graph. That way you can kind of convince yourself, and you see it in front of you. But go ahead and start with the easy part first. See if you can find your b value from the period of 4 pi. Then sketch out a cosine graph and try to, whatever graph you create, make sure the highest value is a -2. And then you can decide how low you want it to go, and you can also decide what amplitude you want. Okay? But I think it helps. I think it helps sketching out a graph. Then you can, if it looks right to you, then you can start building your a value and your d value. So from a period of 4 pi, I can solve for b. 4 pi over 1 equals 2 pi over b. Cross multiply, 4 pi b equals 2 pi. Divide both sides by 4 pi, I get b equals 1/2. So we can use that for our equation. Cosine function, period of 4 pi, maximum value of -2. So I have my subintervals from 0 to 4 pi. Now, I want my max value to be a -2. I know that my cosine graph is going to start at the max value, or at least the parent function, right? We could have created one that's reflected, but I think it's easier with it starting at max, which means that we know the middle has to be lower than -2, right? So I'm just going to make it as easy as possible. I'm just going to make it 1 below, so I can just have an a value of 1. Now, you can have a value of 2. You can make your dotted line even further down, which will change your a value and your d value, which is fine. Those are all legitimate. I'm just creating the easiest function possible. So I'm just going 1 down from my max, which means that my amplitude is going to be 1. And my d value is -3. Right, this is the highest value that I can have for my d value. Well, I guess technically we could have the d value to be a decimal value, right, and then make the amplitude 1/2, but that just feels more complicated. So the nearest whole number I see is -3, so I'm going to choose -3 as my center, which is going to give me an a value of 1. Again, no shift, because I'm just creating a cosine function that starts nicely on the y-axis. Oh yeah, that's you can leave it off. You can just have a parentheses but no bracket. Yeah, I think I was doing this in preparation that there could be a c value, and then I had too many brackets, so it doesn't really matter. Good. Any questions with 3 or 4? Yes. It'll be negative 1. That's what I think you reflected it. We're counting from the center to that's all negative. The negative is correct. We're starting it.
Wait, okay.
Okay, let's look at the bottom problem here. Are we good? Anybody still need to look at number 4? All right, here's number 5. Write an equation of the graph below. I think this looks more like the cosine function, so let's start with the easier one. But it doesn't quite show us the full period, so maybe we want to just extend this graph a bit more so we can kind of see the full period, just to make it kind of easier to work with. But technically we could do it without it, but it's just nice to just be able to see a full cycle of our graph. So this is helpful. We know that each subinterval is pi, so we know the next one is going to be 3 pi and then followed by 4 pi. Oops. Guess I could extend it to the left as well. Okay, it's not necessary, not completely necessary, but just to kind of extend the graph on from both sides. So this is more helpful, right? What's the period of this cosine function? Yeah, from peak to peak, right? 4 pi there. Okay. So I'm going to start gathering information here. Okay, b value is 1/2. Okay, so we're building our a through d values for cosine first. All right, what's the a value? 2, right? There's my center. My center is right at 0. I'm just counting from the center to the peak. That's a distance of 2. And it's starting at the max, so there's no need to do any reflection, right? This is where we want, this is where we expect the parent cosine function to be in terms of the max. Okay, b is 1/2. We just found that. Any shift? No, right? It's starting where we expect it to start with cosine. Any vertical shift? No, right? Our dotted line is right on the x-axis, hasn't moved. Okay, sine function. I'm going to create a sine function that lives nearby with very much the same properties as my cosine function. I'm going to get that picture to show up, write a formula for that sine function, and then at the final moment, I will shift it in the direction to make it match that graph that I see. Okay, so I'm going to create a sine function here. Okay, so I'm just going to focus on that sine graph that I drew. Okay, I made it the same period as the cosine. I made it the same amplitude. So let's create that equation here, or gather information. We know the sine function is a value of 2. Right, this sine is a value of 2. Period is still 4 pi. So our b value is the same. B is still 1/2. Our C value, we'll leave that alone for now. And then our D value, we definitely know is 0. So y equals 2 sine. And now I'm just trying to figure out my final piece of the puzzle. What can I do with this graph in green to shift it to look like the graph I'm trying to target? Okay, I need to go, it's off by a factor or by a unit of pi, so I'm going to shift it left, right? I'm going to shift that green graph left, so I'm going to say what? Plus, yep, plus. Okay, questions there? Okay. Okay, let's get some more practice. So on page 14, this goes back to more of the familiar problems that we've seen. Whereas similar to the format of the homework that you did yesterday. Does anybody still need to look at number 5? Okay. Page 14. I meant to number these, so if we can number these problems on page 14, we'll call this 1, 2, 3, and then 5, 6, and 7 on the next page. Yes. Okay. Okay. First things first, try to rewrite that function with that 2 pulled out so that we can get that phase shift to be correct in terms of interpreting it. After you guys had a chance to try it, I'll show the progress, show the work. Oh, I forgot to mention this. This is something we need to be able to do as well. Domain and range. So can you guys add domain and range? Okay. So domain is easy. Domain is always all real numbers. Your sine and cosine will have no breaks. It'll go on infinitely in both directions. So your domain is always negative to positive infinity. And your range is just going to be from your minimum to your maximum with brackets. Okay. your minimum to your maximum with brackets. Okay, you're good with number 1, go to number 2. Okay, is everybody good with domain and range? Lowest y value is -4, highest y value is 2. Make sure you have brackets for range, parentheses for domain. Number 2, you can do plus or minus. Either one is fine. You don't have to do both, but either works. I'll show number 3 in a second. Okay, is everybody done with number 2? Yeah. Okay, here's number 3. Okay, so first step, got that 2/3 to factor out, and have to ask myself, 2/3 times what will give me pi? I know I got to get that 2 and 3 to cancel out, leave me with just pi, so just going to be 3/2 pi. Double check, 2/3 times 3/2. 3's canceled out, 2's canceled out, I'm left with pi, so if I distribute through, I get back to where I started. 2/3 is my b value, so from there, I'm going to help find the period. 2 pi divided by b is the same thing as 2 pi multiplied by the reciprocal. 2's canceled out, 6/2 is the same thing as 3, I get 3 pi. So that's the full length of my cycle. I have to take the interval, so I can know what to what each subinterval is going to be. Divide by 4, 3 pi over 4. Phase shift is left 3/2 pi, which we'll do at the end, and then plus 2 up 2 units. So starting with the interval, I'm going to start at 0 and keep adding 3/4 pi until I make my way to 12 pi over 4, which is 3 pi. That confirms that we're moving along the right cycle or subinterval. Cosine starts at the max, ends at the max. Multiply by -2, so it's going to start at the min and end at the min. Subtract by 3 pi over 2 because we're moving left, so minus 3 pi over 2. Just to make it so that I can match the common denominator, all these have 4s, so I just subtract it by 6 pi over 4, which is the same thing as 3 pi over 2. Just makes it easier. Have all the common denominators, and I can add them a lot faster. -3 pi over 2, -3 pi over 4, 0, 3 pi over 4, and then this is 6 pi over 4, which is really 3 pi over 2. So we know that plus 2, that's going to be our dotted line. So from the dotted line, we're going to mark each of our subintervals starting at -3 pi over 2. We're going to go down 2 units from the center. Next is 0. Next up 2 units. Next dotted line. And next down 2 units. Okay, any questions? Okay, last thing, let's do some more interpreting of graphs. Can you guys turn to page 13? At the very top, 5 and 6, those are 2 graphs there. For number 5, do the cosine function first, and then build your sine function. Does anybody still need to look at number 3 or 4? Okay. So the reason why I say that cosine is easier is because cosine usually starts at the peak, right? But this is starting at the lowest point. So it's basically the cosine function. We can just think of it as the reflected version. So just look at that. All right. What's going to be our period for this cosine function? Pi over 4, right? Okay. So once you know that your period is pi over 4, we can work towards getting to our b value. Again, this is on page 13, number 5 and 6. Just this may be helpful as well. We know that our period is pi over 4, but our interval is going to be 1/4 times pi over 4, which is 1 or pi over 16. Now, where's the center of this graph? Can you guys spot it? 1, 2, 3. Yeah. So I can basically say that each of these interval is by pi over 16, right? This is pi over 16, 2 pi over 16, 3 pi over 16, 4 pi over 16. Okay. Okay, so we have our b value. What's our a value? Right, so I would say the amplitude is 2, but because we're starting at the minimum, we know there's a reflection going on. So I know my a value is going to be -2. And what's our, so we know our b value, which is 8. C value, we're picking cosine because it's easier to do. So no c value, or c value 0. And then what's our d value? -3. Okay. Okay, are we okay with the cosine function? Okay, I'm going to create a sine function that lives nearby. Oops, sorry, this is wrong. So this sine function is going to share a lot of information as previously. It's going to share the same a value, it's going to share the same d value. We just have to worry about the shift. So still an a value of 2. And I'm making the graph go up, so I don't have to do any reflection. So my a is going to stay as a positive. I can get my bracket going, theta, 8 theta. So what I have here is the graph in green. How much do I shift, and in which direction can I get that green graph to match the graph that is shown originally? Shift to the Which direction? To the right. By how much? Pi over 16, right? Each interval here is pi over 16, so it's just gonna go over one click. So that's pi over 16. So what do we put here? Minus, good, minus. Okay, if you did number 6, you can check your answer here. Okay, so Monday will be our check-in quiz.